Okay, so we'll discuss algorithm. Okay, so what is an algorithm? Algorithm is a set of computational steps to solve a real life problem. Now there are multiple problems we face every day in our real life. Assume that you are going to your class, and on the way you actually faced the need to go to a particular building. So it's like you are starting from a source vertex, which is a source node or a source point, which is like your apartment or your residence, and you are trying to come to Benton Hall for your class. And on the way you need to stop at a Starbucks or a breakfast place or a supermarket to pick up something. So or some other multiple places, okay, multiple stops you are taking. So what you want to do, you want to minimize the the distance covered, distance traversed on this source to destination path with this stopovers. Okay, so this kind of thing we do, like suppose one person is driving from a source vertex to a destination vertex, and he needs to take stopovers for fuel break. Okay, so which distance he should travel and then take a fuel break to maximize his efficiency. Like he wants to make minimum stops to reach from point A to point B, but he also wants to make sure his car does not run into problem without fuel. So there are multiple real life problems where we see that we need to achieve some solution with respect to some input. Okay, so the input here can be a set of numbers, can be one single number. For certain algorithms like graph algorithm, it is like a set of vertices and a set of edges. So multiple different things can be input. Okay, so with a formal definition, an algorithm is any well-defined computational procedure that takes some value or set of values as input and produces some value or set of values as output. So every algorithm must have a set of input and a set of output. Okay, so consider this problem, which is a sorting problem. A sorting problem you are familiar with, which takes a sequence of n numbers, okay, a1, a2, a3, in that way up to an, and the output is a permutation of those numbers in the sorted order. Okay, so it's like a1 prime should be less than a2 prime, should be less than a3 prime, in that way. So if equal to is coming, because if their numbers are not distinct, then they can be equal can be there, but if they are distinct, every number is different from others, then there will be very nice lower to higher ordering, okay, increasing order. Okay, so so this is a problem which is taking a set of integer values and producing a set of integer values as output as well. And the output, the property of the output is that they are sorted, and this to achieve this property of the output sequence, we need a set of well-defined steps, and those are called algorithms. Now consider a sorting problem which is called insertion sort. Okay, insertion sort is a typical special type of sort where suppose you are playing cards and you need to order the cards in your hand before you start playing. So what you are doing, you pick up the first card and check what is this, and see all other cards are lying face down on the table. So you pick the next card, and if it's the next card is kind of less in value, the first card is number 10 and the second card is number 9. So we kind of put number 9 before number 10, okay, following this sorted sequence. So then we pick up, so the 9 and 10 in my hand is now sorted. Now I pick up another card which is like king. So we so now in the left hand the sorted sequence, what I pick in the right hand is not sorted. So now I find a place for the new card, which is the king, and then put it in the sorted pile. Then the left hand is again sorted before I pick up a new card. Okay, so so this is a insertion sort is about that. So it inserts a new element into a sorted sequence. Okay, so it's an efficient algorithm for sorting a small number of elements. So here you see, this is important, a small number of elements. So if there is a large number of elements, insertion sort is not very useful. Okay, even if it's more than like 20, above 25, 29, insertion sort already falls back and it's not doing very good. But for less number than that, it's pretty good. So now you see that so the input size matters. Okay, here input size is a small number of elements. What's the number of elements? You can see that if I give 30 elements, insertion sort will perform one. If I give like 5,000 element, insertion sort will perform in a different way. Okay, it will be slower. If I give 1 billion element, insertion sort will probably crash. Okay, so how many inputs an algorithm can handle? This is the kind of a measure of the algorithm. So the input size can be measured in the number of elements, also number of bits taken by each element. If it's a character, it will take 1 bit. Should not be very difficult to handle. But if it's a double, probably it will be much more difficult to handle than a character. Another property of insertion sort is that it sorts the input numbers in place. Okay, you don't need a separate bucket, separate memory storage to keep the third-party storage for storing your numbers when you are doing the sorting. Insertion sort is actually in the same array. It rearranges the element in such a way that the final sequence is a sorted sequence. Okay, so it's called the in-place sort. This is a very important property. All the sorting algorithms are not in-place sort. Okay, so now after this we try to discuss the pseudocode of the insertion sort. Now what is a pseudocode? Pseudocode is like a code. Okay, if you write in computer program like Java, Python or C++, you'll write a set of steps, set of instructions to get this, achieve this sorting operations final output. Now what insertion sort pseudocode does, so it also kind of states those similar kind of steps like you will write in code, but in a more simple to understand language, and most of the time it's just English language. So within the code you will just find sometime it's just English language, okay, with some logic embedded in it, and it's much easier to understand. And I will show you later that using the pseudocode analysis of algorithm is much more easy, because in that case we can count the steps and see that how much time individual steps are taking. So what does it do? So let me show it with this example here. Okay, so now the insertion sort we will explain with an example. Okay, so you see the sorting problem as a whole is a problem which sorts the set of input numbers. Now when I give a particular set of input, a particular sequence of input, and this is called an instance of a problem. Okay, instance of a problem is a input, a particular set of input given for a problem. So the problem is a more generic thing, and this is a more specific thing. An instance of a problem is more specific thing to the problem. So now, so now we show the execution of insertion sort on a problem instance. Okay, so this is called a problem instance because this is a particular input for a generic problem type, which is a insertion sort or a sorting problem as a whole. So now what we do, we will see that the first time when we pick up a card, which is 5. So initially 5 is in our hand. So when it's a single element array, we assume it is sorted. So 5 is already sorted. So this loop, the number 1 starts from j equal to 2 to a dot length. So this is suppose this is j equal to 2 and up to it goes to a dot length. Okay, a dot length here is the size of the array A. So this is the input, has this the input to the insertion sort, the array A, and now I equal to j minus 1. Okay, so as j equal to 2. So in algorithmic problems, what we say that we start from 1 to the a dot length instead of in programming convention where we do 0 to a dot length minus 1. So I is equal to j minus 1. So that is 2 minus 1, which is 1. I is initially 1, and this part is sorted. So the for loop starts from j equal to 2 to a dot length. So then what we do, what we are trying to do, we are trying to insert aj, which is a key, that is 2, in the sorted sequence. We pick this new card. So this part are the cards on the table, okay? So this is the card we are in hand, okay? Card in hand. I can write here, card in hand, okay? Or just picked, okay? Just picked. Now what we do, we are trying to check where to insert this 2 in the sorted sequence. Now there is only one card, so it's easy. So I equal to j minus 1 we have done, while I greater than 0. Is I greater than 0? Yes, I is 1, so it's greater than 0. And ai greater than key. Okay, so ai greater than key means, now ai is this, 5. Is it greater than 2? Key is 2, you remember. So yes, it is. So what we do, ai plus 1, ai is stored in ai plus 1. So this 5 actually goes to here, okay? ai plus 1 is now position 2 now, and this position is remaining empty at this stage, and I is reduced by 1, I equal to 1. So current I is 1 minus 1, which is 0. So, and then again check the while loop. Is I greater than 0? No, this condition is not satisfied. So remember that the loop, checking the loop conditions are met or not is executed at least one more time than the loop, inside the loop, those the steps. So now what we do, we are now I is equal to 0, so that is loop is, so we come out of the loop. Key is put in ai plus 1. I is now 0, so 0 plus 1 equal to 1. So in the position of, the first position, this key, which is 2, is inserted. So now this is 2 and this is 5, okay? So let me wipe this clean and write this. So now the current condition is 2 and 5, okay? So now this is the sorted in the left hand, and the other element 4, 6, 1, 3 are to be picked. So 4 is now the next element to check. 6, 1, 3 are the cards on the table lying face down. So now this is the card in hand, okay? So what we do, we do the same step. J is now this one, j equal to 1, 2, 3, and I is j minus 1. So I equal to 2, okay? So what we check, while I greater than 0 and ai greater than key, ai is 5. Is it greater than key? Yes, it is. So what we do, we shift 5 to one position. Okay, so 5 goes there, and this position is now empty, okay? So this position is now empty, and what we do, we say that I is reduced by 1. So now I equal to 1, okay? 2 minus 1, 1. So I is coming here, so pointing to 2. And now we check the same condition again. Is ai greater than key? 2 is greater than key? No. So we do not enter the loop. We come out of the loop and execute this statement, which says key will be put in ai plus 1. So I is equal to 1. So I plus 1 is 1 plus 1 equal to 2. So in this position where 5 was there, 4 will be inserted. Key is the 4. So at the end of this stage, what we're doing? 2, 4, 5, okay? And then 6 will be the next element to pick, and 1 and 3 are cards on the deck. So when 6 comes in, so this is the j equal to 4, I equal to 3. Okay, so we go back checking here, and then we find that, okay, 5 is not greater than 6. So then we just, current position of the I, which is 3, and the next position, which is 4, 6 will remain in that position. So at this stage, it is 2, 4, 5, 6, and next card is 1, and the remaining, which is 3, is on the table. So when 1 comes in, so this is j equal to 5, 1, 2, 3, 4, 5, and I equal to 4. Okay, so I will, go back one step by one step until it is 0, and 1's position will be found. So 1, you can see that it should be every time I has to, because this is a kind of sorted sequence. So when we are trying to put 1, so we have to kind of, come at the beginning, every time this while loop will be executed, and then finally when I becomes 0, I equal to 0, then we will make I plus 1, that is 0 plus 1, and in the first position 1 will be inserted. Okay, so in that way finally we will have this. So at this stage it will be 1 2 3 4 1 2 no 3. Okay, so this is 4 5 and 6, and then finally 3 will be in hand and will be checked, and 6 will be shifted by 1 position, 5 will be shifted by 1 position, 4 will be shifted by 1 position, and when we check with 2 we find that 2 is, this condition is not satisfied, 2 is not greater than 3. So what we do, so this will be the i's position, that plus 1, so this will be this position, and here 3 will be inserted. So it will be 1 2 3 4 5 6. Okay, so this is the way of executing insertion sort. I hope you understood the pseudocode, how it runs. One more time just to tell you how it is working. Initially there's a card which is in hand, then we pick up a card from the deck on the table, from all the cards, a pile of cards which are lying face down, and check in the sorted sequence. So this part will always be the sorted sequence. Okay, so this part in hand will be sorted sequence. Okay, sorted, and this is the card in hand, just picked one, and then remaining are on the deck. Okay, lying face down. So, and then what we do in the sorted sequence, we check whether the newly picked card is greater than that or less than that. If it's greater than that, then it will be inserted. After this, we increase I by 1 and insert that. If it's less than that, we keep checking backward until I is 0, that means till the first card, and shift them one by one until we find the proper place for the new card. Okay, so now we'll do the analysis of the insertion sort algorithm.